Hello everybody, and welcome back to our lecture on Introduction to GIS, and this is the third of three. The first one we discussed the fun parts of GIS in general. Second lecture we discussed the ArcGIS family of software, and in this lecture we're going to discuss ArcMap in particular because that's the one we're going to be using most. And ArcMap is a component of desktop, so we're also going to be using ArcCatalog quite a bit. This course will work with ArcMap. We're not going to cover all of what ArcMap can do because it would really take much more time than we have, and honestly I doubt anybody's really an expert at everything ArcMap can do anyway. I've been a hardcore GIS user for over 20 years and I am constantly finding new things it can do. And if you'd like, you might want to open up this particular ArcMap document called WallowFire MXD. This way you can try some of the ArcMap functions as I described them here. So if you go into your data folder, you look in the folder called Wallow, then there's this wallowfire.mxd. If you find it in Windows File Explorer, you can just double click on the file and it will open this ArcMap document right up. For now, don't worry if you see these messages. These are just little warning messages that ArcMap pops up every once in a while. This thing about geographic coordinate systems, this is actually a really important thing to know about. So where you see a little option that says don't warn me again ever, don't click that. Leave that alone. We want to know when we have different geographic coordinate systems come up. And we're going to talk about this a lot more when we discuss projections and datums. But for the time being, just don't worry about these if and when you see them. And if you see this particular message about hardware acceleration, just go ahead and say yes. I'm not sure really what difference it makes, but I've never had trouble with it running. All right, so now let's look at ArcMap itself, and let's look at how ArcMap is set up. And also, as we go through this, I want you to know that Esri terminology is important, and Esri terminology is not intuitive. So I'm going to be calling some things by their names, and I really want you to understand what I'm talking about and to learn the name, even though the name doesn't make sense. It'll just make things easier for you later. So try to learn the correct names for the ArcMap components and functions. Now, looking at the major components of ArcMap. First off, ArcMap is divided up into layouts versus the data view. It's just two ways of looking at your data. First up is the data view. This is typically used when you're analyzing or creating data. If you're only doing analysis in some particular project, like you're not ever making a final map, then you'll probably never even switch out a data view and into the layout. But anyway, here we see the data view. We click this other button at the bottom and we switch over to the layout view. This is typically used when we're designing a map that we're going to export or print. Layout is the thing that contains additional map components like legends and titles and scale bars, north arrows. None of these things exist in the data view. They only exist in the layout view. Now, data frame. This is one of those ArcGIS Esri terminology things that doesn't make a lot of sense. A data frame is a map. Now, ArcGIS can have multiple data frames like you see here. And each data frame is a separate map with its own set of data. And one common strategy people take is to have a single primary map that has all the things that you really want people to focus on, maybe a timber sale or a fire boundary or something. Then you might have a larger region in a separate data frame to help the map user orient themselves, maybe figure out what forest or county or state that this primary map is located in. Now there's also a concept called the active data frame. ArcMap can have multiple data frames like we see here, and just to be clear, one data frame is named layers and it has all that stuff with the WallowFire. Another data frame is named reference data frame and it has the background states and country boundaries. Well, one of these is what we call the active data frame, and ArcMap always has a single active data frame. One of the frames is always active, and only one can be active. The current active data frame is always shown in bold in the table of contents. In this slide, notice the data frame named layers is in bold, while the reference data frame is not. This means that layers is the active data frame. Now in the layout view, the active data frame has this dotted line around it. In this slide, notice that the data frame named layers, it has the blue arrow pointing to it. It has a dashed line around it, while the data frame reference data frame, the one with the red arrow pointing at it, it does not. Again, this is further confirmation that layers is the active data frame. So what does it mean for a data frame to be active? It's really an important thing. When you add a legend or a scale bar or a north arrow to your layout, ArcMap generates it for the active data frame, and this is important to remember. A very common error people make is to generate a scale bar for the wrong data frame and put it in their layout. In this slide, imagine that the scale bar actually showed the scale for the reference map of Arizona and New Mexico rather than the scale for the Wallow Fire map. And people do this a lot. In this example, it make it look like the Wallow Fire was hundreds of miles across. So when you add data to your document, ArcMap will also add it to the active data frame. Now the data view, if you switch to data view, it shows only the current active data frame. The layout shows all of them. So in this slide we have switched to the data view, and notice that we can only see the data for the layers data frame. We no longer see any background state or county maps or country maps from the data frame named reference data frame. Now here we're still in data view, but we have changed the active data frame to the other data frame called reference data frame. Now we see the states and countries, but we no longer see any of the data from the Wallow Fire. To change the active data frame, either click on it in the layout view, or you can right-click on the data frame name in the table of contents and click Activate. Now let's look at some more pieces of the ArcMap interface. This thing over here on the left is called the table of contents, and this lists the data that is currently in the map document. And there's several ways to sort the data in this list. First off, we can sort by drawing order, and in this option the layers are sorted in the order that they are stacked in the actual map. Notice, for example, that the hillshade is at the bottom of the list in the layers data frame, and it shows up underneath all the other data sets in the actual map. This option makes it easy to change the way the map looks just by dragging layers up and down in the drawing order. Now notice that this sort option shows the layers in all the data frames, both layers and the reference data frame in this slide. Another option is to list by source. This option lists the data by the data source workspace location, and we're going to cover workspaces in more detail in the next lecture on data types. But in general, a workspace is just a container for data. An Access database is an example of a workspace, as is a folder on your hard drive. Now notice that this sort option shows the layers in all data frames, again, both the layers and the reference data frame in this slide. The third option is to sort by visibility. This just sorts the layers by whether the visibility for that layer is turned on or off. Notice that this sort option only shows the layers in the active data frame. Then the last option is sort by selectability, and we're going to go over selectability quite a bit in another lecture. But here we can set whether certain layers are selectable or not. And notice that this sort option also only shows the layers in the current active data frame. Next up, map scale. Map scale seems pretty intuitive. I think we all kind of know what it means. We know if it's a 1 to 24,000 map, that means that a 1 inch on the map is equal to 24,000 inches on the ground. There's a couple things to understand about how ArcGIS is treating it, though. First off, the scale when we're in the data view like we are here, the scale is only an approximate scale on your computer monitor. It's not exact because ArcGIS doesn't really know how big your monitor is. Now when we shift over to the layout view, on the other hand, scale reflects the scale of the active data frame as it is positioned on the layout. Now this scale value is exact because ArcMap knows exactly how big the layout is. Now large versus small scale. Now these terms sound obvious, but they're really not. They're not intuitive. Most people get these terms mixed up. People who do know the correct definition often get cranky when people use the wrong definition. I recommend you try to avoid the terms large scale and small scale if possible. Now, if you look at these examples, you notice the Wallow Fire, which is zoomed close in relative to the reference scale. The Wallow Fire is actually a larger scale than the reference map. And this is the counterintuitive part. A lot of people sort of assume that if the map is showing a larger area, that means it's a larger scale. It's a reasonable assumption to make because that's how large scale is treated in most other fields. If you have a large scale development, then it's going to be a bigger building than a small scale development, right? Well, not when it comes to cartography. Large scale maps mean a small area. Now, why is it called large scale? Well, maybe because people treat it like a fraction. A 1 to 24,000 map is a larger number than 1 to 1 million. And so a 1 to 24,000 is a larger scale than 1 to 1 million. You might also think of it meaning that a small scale means a feature looks small, while a large scale means a feature looks large. Once you learn these terms, I do recommend you try to avoid using them because people do make the mistakes, and it's not unreasonable that they would mistake it. In fact, I review GIS-related scientific papers for journals all the time, and I'd estimate about half of the articles that I review confuse these terms large and small scale. This is amongst professional map makers and data scientists, so it's understandable error. So this is why I recommend you avoid these terms if you can. Even if you use the terms correctly, there's a good chance that your audience will think you mean the opposite of what you intend. Okay, let's get back to the ArcMap interface. These numbers in the bottom right corner are the coordinates, and when we're in data view, as you see here, these coordinates are in the coordinate system of your map, and they show you the coordinates of the mouse as it's wherever you have the mouse sitting over the map. Now we're going to talk about coordinate systems in a future lecture, talk about projections and datums, but you might be familiar with the terms UTM or latitude and longitude, and depending on what your map is set up, that's what these coordinates will be in. When we shift to layout view, we actually have two sets of coordinates. We have that first set that shows you the mouse position in the actual map, as it lies on the landscape. Then a second set of coordinates that shows you where the mouse is in the layout page itself. Now, remember that the layout is set up as if it's a piece of paper, and you're putting things on the piece of paper here and there. Well, piece of paper has its own coordinate system, and so you get both coordinate systems when you're in the layout view. Now, if you moved your mouse from one map to another, well, those coordinates that show you the map coordinates, those would jump drastically. Next up, let's learn about layers. Layers seem pretty simple, but they're actually more complicated than they look. Most important to understand is the layer is not the data. A layer is a set of rules that tells ArcGIS how to display the data. It includes things like symbolization and what scale to show it at, what parts of the data set to show, what other characteristics that we'll cover later. But in the simplest sense, though, the layer is the thing you see in the map. But understand it's a set of instructions on how to draw it and also where to find it on the hard drive. The data itself is not stored in ArcMap, only the layer is. Now in this slide, notice how the layer visibility can be turned on and off. There's check marks in the boxes next to the layer names, and you just click them and the layers turn on and off. In this case, burn severity is visible, but fire history is not. Also notice how symbology can be collapsed. There's a little plus sign next to the hillshade in the states layers, or expanded. There's a little negative sign next to the other layers. So you can expand or contract them just to kind of help save space in your table of contents. Now I mentioned that layers are a set of instructions on how to draw and where to find the data. This layer grouping is one set of instructions. You can put a bunch of layers in a single group, and then you can turn the entire group on and off just by clicking the little check mark. You can also set the layer so that it is only visible at certain scales. If a layer is only visible at certain scales, it will have this gray check mark if the data frame scale is outside of those boundaries. So notice that several layers in this roads group layer have gray check marks, meaning that they are set to be visible, but they are not visible at this particular scale. In fact, the layer names kind of give you a clue for what scale it's expecting. You see there's one check mark that's nice solid black for the roads parentheses 150 to 50K scale. Well, you notice our map itself is at 101 to 122,000 scale, which is within that range. And so that particular layer is the only one that actually draws at this scale. If we change the scale of the map, one of these other layers will become visible. Now, a common strategy for interactive maps is to group several layers that represent the same thing. In this example, we're doing it with the roads. But you set the layer properties differently for each individual layer so that each shows a different level of detail. Then you set the scale dependency differently for each layer so that only one of them shows at any particular scale. Like in this example, that single rows 1 to 50 to 50K is visible, but all the others aren't. And then as they move in and out, you just get a different level of detail with the roads. Now to get to the scale dependency, you open up the layer properties for that layer. You can do it by either double-clicking on the layer name, or you can right-click on the layer name and go down to Properties. Now, once the Layer Properties window is open, you just click the General tab to see the scale range. Now on this slide, observe that the layer named Rows 150 to 50K is set to be visible only if the map scale is between 1 to 150,000 and 1 to 50,001. Now if we zoom our map into 1 to 124,000, then the roads 25 to 15K becomes visible, and we get a different level of detail, different symbology, and street name labels. Now I like layer transparency. This is a neat layer quality, another set of instructions on how to draw. It's fun to play with and can be really helpful for making sophisticated maps. Now, for example, maybe we want to illustrate the topography of the landscape. This that we see here is called a hillshade. A hillshade does really well for showing topography. We can see where hills are, we can see where ridges, where drainages go. Downside of it is it doesn't really differentiate between high and low elevations very well. Now, on the other hand, a DEM, a digital elevation model, is perfect for illustrating elevation gradients. It shows us high versus low. We see high elevation in green here, low shades down into brown. Here we can really tell where the high versus low is, but it's become hard to see the topography. We can kind of see it a little bit, but we lose a lot of the detail. The hillshade was great for topography. The DEM is great for elevation. What if we want to see it both together? Well, we can do that. We can set the transparency for the DEM to be partially transparent. That way we can still see the color from the DEM, but we can see the hillshade underneath it. And it gives a nice three-dimensional effect to the landscape, and we can still easily see high versus low elevation. To set the layer transparency, you open the Layer Properties window again, and you can do that again by double-clicking on the layer name or right-clicking on the layer name and going down to Properties. And then you go to the Display tab to set the layer transparency, and you can set it anywhere between 0 and 100%. Okay, next up, Basemap layers. These are a special type of layer that ArcMap treats differently than others. Basically, ArcMap makes them draw especially fast, so they're good for background maps. You can set drawing properties for basemap layers, but you can't select, you can't edit, you can't analyze them. Any normal layer can be turned into a basemap layer simply by dragging it down into the basemap group. Now you can create a new basemap group layer by right-clicking the data frame name, then choosing New Basemap Layer. You can then drag any of your current layers into that basemap group layer. Now ArcGIS comes with a lot of online layers that are ready-made to put into basemap groups. So if you have a fast internet connection, you can add any of these online basemaps to your map just by clicking the down arrow next to the Add Data button. Then you choose Add Basemap Layer. These online basemaps can be very useful and attractive in a map. They make an easy way to show where your focal area lies in the broader landscape. This National Geographic layer is widely used because it just looks so good. You know, National Geographic is famous for beautiful maps. That's their thing. Now, you also see a nice imagery layer in this. Esri does have a pretty decent imagery layer, and it's down to about a meter or so resolution, so it's really useful as well. There are thousands more online datasets through this ArcGIS Online. In fact, if you put your own data on ArcGIS Online and you make it public, then other people can add it just by going to this option here. And sometimes you really need to be careful about what you download too. It's of variable quality, I guess. Sometimes it's just sort of thrown together like a student project and they're just putting it on the web to see if they can do it, but it's really not any good or accurate. And quite often it's put up in a way that you really can't do anything with it, even if you do download it. So it can be tricky. It can be really frustrating to use data from ArcGIS Online. Just a heads up. Now in this example, we have added the USGS topo maps into our basemaps layer, and this is a really nice online data set I highly recommend. If you've ever used the 1 to 24,000 quads, well, you know how cool they are, and you have access to the entire country through this single basemap layer. And then there's more. Just like you can download data directly into ArcMap from the Esri site or ArcGIS Online, many other agencies and businesses have provided links to their data directly for ArcGIS. In fact, in the next lecture, there's a lab exercise that gives you a PDF with thousands of online data sets that you can link directly into ArcMap. And it shows you how to do it, and it's really pretty easy. There's also data sets that you can just download directly onto your hard drive and they become like a shape file or a geodatabase, and you just download it from a website and it acts like any other spatial data on your computer. And this Forest Service data is a good example. A lot of the Forest Service regions have data sets available. Region 3 does an especially good job of it, and you can download and use almost all the data they have available, all their roads or stand boundaries or grazing allotments. All this stuff you can download and you can use in your own projects. Now, some sites have tricky data. They have great data, but it can be complex and difficult to work with. So some sites actually provide special tools to help you get their data. And Landfire is a good example of this. Landfire data downloads in weird ways, and sometimes in lots of pieces with attribute data unconnected from the primary dataset. This particular Landfire download tool lets you download only the area you need, and then the tool combines all the pieces and attaches the attribute data and provides you with a single data set that's easy to work with. So Landfire is pretty nice and especially applicable to forestry. There are lots of data describing vegetation characteristics and fire-related information, and the dataset covers the entire country. It categorizes vegetation in lots of different ways. The website's the best source of info. And just to clarify, Landfire doesn't actually have fire data. They have fire modeling data. There's several other websites that are good for fire history, fire boundaries, and fire severity. Okay, moving on. Now, when you're working with ArcMap, you're going to be working with map document files. Map document files have this star.mxd extension, as you can see in this slide. The file name wallowfire.mxd is a map document file. If you double-click on it, it will open up an ArcMap. ArcScene documents have .sxd extensions, and ArcGlobe documents have .3dd extensions. Note, if you do not see this extension .mxd in Windows Explorer, then you can change the setting in Windows Explorer to let you see them. Instructions on how to do this, how to see file extensions, are attached to the end of all the homework assignment documents. Now, one very important point is that the map document does not actually hold any data. It only stores references to the data. It knows where to find the data and it knows how to draw it. But it does not hold the data itself. And this is good because it lets you add huge amounts of data to the map document while keeping a small file size. This does make it difficult to share MXDs, though, unless you share the data separately. Now, regarding your homework assignments, and this is really important, several of your homework assignments ask that you send me spatial data. Now, please understand that the map document file does not contain the data. You may see the data in your map document while you have it open on ArcMap on your computer. It's only because ArcMap knows where the data is on your computer. If you send me that map document and don't have the data with it, then I'm just going to get an error message when I open your map document. The error message says that ArcMap can't find the data associated with the layers. So never send me an MXD file unless I specifically ask for it, and I'm not planning to ask for it. If the homework asks you to send a shapefile or some other spatial data set, do not send the MXD. MXD does not have the data. Send the data. So this is an issue that causes a lot of confusion for most people who are just starting out with ArcGIS. Just remember that an MXD, this map document file, does not contain data. It only contains information telling where to find the data on your hard drive and instructions on how to draw it. One analogy that jumps to mind for me is that if I'm on a fire and I ask for a chainsaw and somebody runs off and brings me back a picture of a chainsaw, well, that picture doesn't do what I need the saw to do. And this is kind of what it's like to bring an MXD when somebody asks for data. So don't do it. It's just embarrassing. Now, how do you know where the data is actually located? It's in the Layer Properties window, and we've seen this before. This time, if you go to the Source tab, you can look down here in the Data Source box, and you can see where the data is sitting on your hard drive. Now here's an interesting and maybe a little bit technical point. It turns out it's really important in certain cases, and those cases are kind of rare. So there's a fair chance it's not ever going to come up for you, but you should know about it, and so I'm going to explain it to you. This idea of absolute versus relative path names. An absolute path name means that the entire path name is stored in the layer properties. In this slide, the map document Flagstaff Road will store the entire path name for this dataset leading up to highways, and it would expect you to find this file at this particular location on your hard drive. It would be in this exact location on the D drive. Now, a relative path name means that the map document looks for the dataset in some location relative to the current location of the map document file itself. In this slide, it would only store the path data/Flagstaff FGDB/highways, and it would expect to find the folder data in the same location as the map document file. Now, either location may be appropriate for you depending on your data organization. Now, absolute path names are best if you expect to move an MXD on your hard drive, but don't expect to move the data. You got the MXD on your C drive and all your data is on your D drive, and all you want to do is copy the MXD from your C to your D drive. Well, your data is still on the D drive and the map document knows where to find it. Absolute path names are also better if you share MXDs with other people and those other people all have access to the same spatial data in the exact same location. And you might get this if everybody in your organization has the same network drive. Now, relative path names are better if you want to share an MXD plus all the data. You put all the data in the same folder as your MXD, or maybe subfolders within that folder, and then you'd simply share that entire folder. And that's actually what I did to create all this data that you guys are using for your lab exercises. Now, if you don't intend to share an MXD or move it around on your hard drive, then it really doesn't matter which option you choose. It's really not going to make a difference to how ArcMap works for you. So that's usually the case. Most people aren't trying to move MXCs around, and if you're not, then this isn't going to be an issue for you. But if you ever do wind up with these error messages, you get an MXD and it won't show the layer, all it shows is a little red exclamation mark, well, this is the problem. Fortunately, it's easy to fix. So here's how you change it. As I mentioned before, if you want to change your map document, switch it from relative to absolute path names, you just click the File menu, scooch down to Map Document Properties, and then you'll see this Path Names option where you can change it to relative. Now here's the problem. This is what you'll see if you have done it incorrectly. You open up your map document, you see all the layers listed in the table of contents, but none of them are drawing. Instead, all you see is these red exclamation marks. Well, these red exclamation marks are the sign that ArcGIS can't find the data. Happens a lot when you move an MXD. Now, fortunately, there's a Repair Data Sources tool that usually lets you fix this problem without too much effort. You right-click on the layer, you go to Data, then Repair Data Source, and if you have multiple layers that all suffer from the exact same problem, they're all in the same location, then fixing one will fix all of them. So that's kind of nice. Just a few more things I want to cover before you all go start working on your lab exercises. There's a few other windows that you have available to you in ArcMap, and one of them is this little catalog window. This is similar to ArcCatalog, but not quite as full scale. It's just a separate little sub function that sits within ArcMap itself. So you can do most of the things you can in Catalog using this little sub window. Next, there's a search window. This search window can be used to find data, map documents, or tools. Now for data it's a little tricky because you have to prepare it first. You have to index all your data and you have to set up this indexing schedule, and it's kind of a hassle and it seems to crash a lot. So I'm not sure that the searching for data is all that reliable, but this search function is great for searching for tools. And then we have an Arc Toolbox window, and this has most but not all of the tools that you have available to you in ArcGIS. We're going to go into more detail on these in a future lecture on geoprocessing. Now, all of these little separate windows can also be detached from ArcMap and be dragged around to different parts of your monitor. This is kind of nice when you have multiple monitors. You can take all these little separate windows and pull them onto a different monitor, and that gives you a full monitor to do your mapping work with. Next up, toolbars. These toolbars can also be docked to ArcMap, and they're optional about which ones you want to show. They can be docked to any edge of ArcMap, and in this particular slide I'm showing the standard toolbar, the layout, the editor toolbars docked to the top of ArcMap. I have the Tools toolbar docked to the left side, and then I have the Draw and Graphics toolbars docked to the bottom. These are toolbars I use a lot, and when you first start ArcMap, you're probably not going to have all of these turned on. So it's just up to you which tools you like to have available. Now these toolbars, they can be docked like we see here, or they can be floating, similar to those other windows. Floating toolbars, you can drag them all over the place, put them on a different monitor if you like. Now, there's a lot more toolbars that are available. You can find them multiple ways. You can find them by clicking the Customize menu, then the Customize mode. Then you'll see all these toolbars. You can just check off the ones you want to turn on. You can also right-click on an empty spot in the toolbar region. You'll see another list of all these toolbars, and it's just a different way to turn them on and off. Now, toolbars actually don't hold tools. It's a weird technical thing. This goes back to the ArcGIS terminology I told you about earlier. A toolbar does not hold tools. A toolbar holds commands. Tools are those things that are in the Arc Toolbox. So anyway, there's a lot of commands that are available to you that aren't actually on any toolbar, and you can load and work with any of them if you want. You just have to know how to get to them. I really like this continuous pan and zoom command, and in fact I like it so much that I have a lab exercise that shows you how to add it to one of your toolbars yourself. And finally, for those of you who are comfortable with computers, if you like doing little keyboard shortcuts to make things faster, there's several keyboard shortcuts available to you in ArcMap. These holding the Z key down as you draw a rectangle, that makes you zoom. Different ways to pan and drag around. If you do this a lot, these keyboard shortcuts will be really useful for you. And if you're interested, you can look in this document, ArcGIS Desktop Tips. It's in your Documents folder, and it'll give you all the shortcuts that are hardwired into ArcMap. I think that about wraps up our introduction to GIS. In the next lessons, we're going to go into more detail on data types and how to select projections and datums. Then we'll really dive into some cool tools and analysis. It ought to be fun, and I look forward to seeing you there.